Hi, this is Joris Peels, and this is the 3D printing news Unpeeled with 3dprint.com. So, thank you very much for being here again today. And we're going to give you another little roundup of the news. So we hope to be succinct and insightful, and we hope that this will deliver value for you. So, we have 6 news items for today. And the number 6th item is that the University of Pittsburg is buying a Gefertec ARC 605. So this is a German machine. That's a WAM machine that uses wire. So that's a safer feedstock, especially in like a military scenario on board a boat, that kind of thing. And it makes near net shaped components, which then need to be machined to be the right size and all that. It's really inexpensive to print parts on this machine, and it really enables much larger parts than we're used to. So especially for repairing components, larger scale components, things for the military, this is a really very relevant technology. So the first project that they did with this at the University of Pittsburg was a 3-foot long bridge. So a bridge component, and that's not a component that normally we would tackle with any of the other technologies. So that it's kind of seeing how we're forging ahead. Also, I think this news is notable because, well, up until now, there's been a lot of research into powder bed fusion, and also laser and electron beam powder bed technologies. But universities traditionally haven't done a ton of work with DED processes and WAM. So it's nice to see a university get in and try to do this. And I really do think there's a lot of military applications here. So that's why I'm really following this kind of news to see what will come out of that. The number 5 news story is 3D printing insects, algae, and plants. This is from the Singapore University of Technology and Design, where they're looking at food security, which is a priority, of course, for Singapore because it has to import nearly all of its food. And they do a lot of research on this because of this. They're looking at the energy that goes into food and the high cost of making meat protein. And what they're trying to do is something. It's like a very logical solution. I'm still not entirely sure if it'll work. So what they're trying to do is they're going to make multi-component inks, right, for vegetables, nutrients, but also algae and also insects. And the idea is to combine these things, so multiple inks in every 3D print, to make kind of insect food more platable. Now, to me, this insect thing, I still don't understand if it's really that efficient when compared to just plant protein. Why would we go to insects? Are there scavenging stuff that will go to waste anyway? Is that why it's interesting? The economics that are clear, not unclear, are still unclear to me. That's one thing. The second thing is, I think, this is just a cultural thing. I mean, insect food, you either find it like night markets, or you find it at like a sustainability trade show or something like that. And it just isn't really happening, and it hasn't been happening for a long time. So I'm really skeptical about that. But hey, this is a really unique approach to trying to solve that problem by turning it into something else. I think the idea of eating an insect is what bothers most people. I'm not sure if 3D printing part of it with an algae protein, an animal protein, and a fortified carrot powder is really going to really do that for people. But I like this because work like this is to me very exciting, because imagine an institutional context when you have somebody who has, for example, dementia. They have to eat food. They don't want to chew a lot of food because they're not very good at that anymore, and they need like kind of like their medicine or the right nutrients. I could really think of like 3D printing these combinations of these inks to get that person the nutrients they need and the easy chewable but still kind of really nice experience type food. So that to me is very exciting. Now, whether we need to put insects in that, I don't know. I'm not sold on it, but I do like the way they're doing this and the creative approach. And I think a lot more can come of just working in these functionalized nutrients and packaging them and using 3D printing. Number 4, the news item number 4 is Welsh startup Mutiny Shaving makes a bound metal shaver. So the R1 shaver. Now, the first one they claim it uses zero waste, is carbon neutral, uses zero pollution, and is the most eco-friendly razor in the world. Now, I know how you could compensate a couple of those things. I'm not entirely sure how you can compensate all of them. So I'm a bit skeptical of their core kind of claims. It's interesting and also nice, I guess, that the company's trying to make the most eco-friendly razor, especially since, this whole disposable world, which we came in, started with Mr. Gillette, realizing that every man wanted to shave every day, especially if they were reinforced to believing that was a necessity, and that these razors would then be disposable and then would forever be kind of a cycle of selling them and then them being disposed of. That got started with the razor. Like after the Crown Cork, the razor was the first mass-produced product that was just disposable, and that's the key thing to the world here. So that's it's quite nice that then specifically for the razor they're trying to make a more sustainable one. Although I do think that the old straight razors are incredibly sustainable and work for many decades. So I doubt that it's more sustainable than that. But anyway, it's also interesting, by the way, that I think Gillette has patents on 3D printed razors. So I'm not entirely sure that well, they're probably not getting in trouble for this. But anyway, what they also do, what Mutiny is also doing, is they're doing plastic recycled razors out of fishing nets and that kind of thing. So I'm a little bit skeptical about the company's claims so far, but we have had very little to no success in rolling out consumer products with 3D printing. And now all of a sudden they're using bound metal. So bound metal, the process, from Mark Forge by SF, some others you can get it from as well. That's kind of interesting because that is a whole new price point. It's very limited in the kind of design space, but the costs are really quite spectacularly low for 3D printing. So to me, it's like, wait, should we revisit consumer applications with lower cost metal printing technologies and lower cost, lower cost just FDM printers as well? Because like for a lot of parts, we don't really need like a part to look really nice, or we could maybe use like industrial size finishing equipment together with an array of desktop printers that are very cheap to make really inexpensive parts. So maybe it's time to look a little bit at the consumer space again without having to pay the high cost per part that we used to. News item number 3: Horizon's Attract Ahead project to make cooling devices. So there's a Horizon 2020's EU project. They have a project called Attract. Attract then gives out funding to other participants, and one of these is the head kind of grouping of companies. It's CERN, actually, working with Thales, Alenia Space, CSAM, DC Aerospace, Nano Energy, and the Norwegian University of Science and Technology. Now, what they're trying to do is they're making smaller, lightweight cooling systems with fewer components. So far, kind of, par for the course and what people are trying to achieve in that space. CERN has done some work in this area as well. And it's notable they're involved because cooling would probably be something they're very interested in. So first off, lower mass, higher performance cooling systems. We've seen that. I'm incredibly excited about heat sinking, heat sinks, heat exchangers, and any of this kind of cooling kind of area. I think we can really do a lot by reducing components, reducing mass, and coming up with optimal geometries. Now, here they mention something. This is really the one of the biggest reasons that this is news item is here. Is they say that they can get higher performance, but also put the cooling element or device, whatever, closer to where the cooling is needed. And that is something that I did not realize at all. This is very logical. It's very obvious. And it could have some really big impacts for people. So they also talk about, maybe working on geometries for natural refrigeration plants, which is a completely other scale, which I think is also, that's kind of fantastical. I'm not sure how much of that is true. And this is another thing I did want to mention is that they're using several different 3D printing technologies to do this. They're not just focusing on one technology. So you could easily imagine making some of the brackets from bound metal or something, some precise components with binder jet, and some other components with lattices from powder bed fusion. And I really like the idea of combining different 3D printing technologies. I complained about this before, that we all kind of focus on our own ballywick or whatever, our own technology, and we don't end up making these technologies work together very logically. News item number 2 is FDM printed lampshade with controlled appearance. Now that is a horrible title for a news item because it's actually a title for a patent. It's a patent that Signify has. Signify used to be called Philips Lighting, or everybody used to call them Philips Lightning, but the Philips Lighting. And they are actually using 3D printing at scale to make many, many luminaries. I don't think they've ever disclosed just how many, but it's a very big operation. They're making thousands of them. Then they got a patent for something that I really want to bring into attention because it's important. Because what they're essentially doing in the patent is saying that we're going to crisscross different FDM layers. right? In order to get an optical or decorative effect. And what they're going to do is use the concentration of these layers, right? And also they're going to vary the amount of additives in the material. So additives, think of like glass bubbles or carbon fiber, short strands, or maybe even a plasticizer or some kind of agent, or some kind of little small reflective parts perhaps. So additives are usually added to chemicals by a compounder, and they make a bog standard chemical, the perfect chemical for, or the perfect polymer for your particular application, that dashboard of your car. And these additives do all sorts of things to the longevity of it, the UV resistance, all sorts of things. So what they're trying to do here is something very logical. I think from Signify's viewpoint, it's very logical they're doing this, and it's a very, very good move. But what they're doing is saying we can. So first off, a lot of people may not realize this. You can focus. You can, rather than putting what you normally do in a compounding scenario, is you mix in all sorts of additives, and you're trying to get it as homogeneous as possible throughout the filament strand. Often these are then cut up again, and then you have granulate. But for filament, of course, well, sometimes these are then taken again and then made into granulate, which is a bit confusing. But the granulate is made into filament. But um, but then you're trying to spread it out. But focusing and concentrating these things can also have different effects. So that's a very interesting thing to consider if you haven't thought of that before. The other thing is that they're literally patenting a way for a print to be used with optical effects through crisscrossing the layers and changing the concentration of additives. And that can be very limiting for a lot of people that would want to do something with the transparency of this print, or the way it reflects light, or the way it lets through light. That's something that not a lot of people have looked at, but I think if we're going to look at lighting generally, but also kind of industrial components, that's something that's going to be considered more. And we have to realize that this, from the point of Signify, makes a ton of sense, but could be very limiting to other people working in the same space, because there's only so many ways to make that geometry. Now, the reason that this is here is it has to do with the number one news item. That it took me like a couple. I've been thinking about this for. It came out a couple of weeks ago, and it was on Marks and Clark or something, like a legal blog. And I've been thinking about it, and I've been facilitating through. This is going to be like really not impactful, or it's going to be huge, and I don't know. Essentially, the number one news item is that the EPO confirmed that you can get patentable Gcode. You can patent Gcode in Europe now. Okay, so what does that mean? That means that they're explicitly saying, or explicitly pointing to the fact that the STL itself may not be protected, but the instructions for assembling the object, the instructions for building this object, the actual Gcode, the machine code, is patented. Now that has an implication for a lot of people in a patent scenario, and also what you protect and what you send to people, what you share, and also has some interesting limitations. So if I change the Gcode, or if I change it somehow, or if I end up building the same object, right, but it has completely different Gcode, right? So I make a reverser, and then I actually copy the object, but I change the Gcode completely. Will it then that then apparently would not have that protection as much, or maybe it will. And then at the same time, these instructions for the additive manufacturing device, which the EPL wants to help patent, are going to be really also kind of very limiting. So you could imagine people getting away with copying all sorts of different shapes and all sorts of different optimal constructs. Like imagine, for example, I talked about this before in a couple of articles as well. Imagine I have the optimal heat exchanger design. If I patent that, and if I patent the G-code for making that, I could maybe take some design elements and certain cues, and I could own that geometry. And that would be a very, that'd be a new way to look at that. So I think that's maybe a bit arcane for people, but I think generally the thing is that we have to really start thinking about mining these geometries and protecting these geometries, because if you don't want to, or even if you don't believe in patents, or if you don't like them, somebody else will do it and it'll limit what you can 3D print. So that's something to take into account. Well, thank you so much for your time today. I hope it was valuable to you. I hope this is useful. Share it, talk about it with people, and and have a great day.